Have you ever just stood there looking at the ocean and wondered what it's really like down there? I mean, up here on the surface, the world is, well, it's familiar. The rules of physics are what we expect them to be. But just a few feet below the waves, everything changes. The ocean becomes this alien world that literally bends the rules of reality as we know it. So that's the big question, right? What actually happens to your body, your senses, the very air you're breathing when you're 30 meters deep? Well, we're about to take a little trip into a world where the laws of physics get wonderfully, wonderfully weird. Okay, so our dive begins. The first things that change, they're not what you see, but what you feel. The second you slip under those waves, your body starts a whole new conversation with the water in ways you probably wouldn't expect. And the very first thing you're going to feel is the cold. Yeah, even in warm, tropical water. And that's because water is an incredible thief of heat. It pulls warmth away from your body 20 times faster than air does. It's a process called conduction, and it's exactly why a wetsuit isn't just about being comfortable. It's about survival. Your body just can't make heat fast enough to keep up. It's not just heat either. Sound gets completely scrambled. It actually travels 4 times faster in water than in air. Now you might think, hey, superpower, I can hear better. But it has this bizarre side effect. See, the sound waves hit both of your ears at almost the exact same time, which makes it nearly impossible for your brain to figure out which direction the sound is coming from. A boat engine could sound like it's right on top of you when it's really hundreds of feet away. It's totally disorienting. And then there's the light. The deeper you go, the water acts like a giant filter, just stripping away colors one by one. Right as the first to go, poof, it's gone by just 5 meters. Then orange, then yellow. By the time you get down to our 30-meter depth, your whole world has become this beautiful, but very different, landscape of blues and greens. Oh, and your eyes? They're playing tricks on you too. Light actually bends, or refracts, when it goes from the water through your mask into your eyes. This makes everything look about a third bigger and a quarter closer than it really is. But, and here's a weird twist, if the water is murky, a strange thing called visual reversal can kick in, making things in the distance seem even farther away. Your senses are just all over the place. So yeah, your senses are completely scrambled. But as we keep going down, a new, much more powerful force starts to take over. The immense, crushing weight of all that water. And this is where the physics of diving gets really, really serious. To understand what's happening, we have to talk about something called Boyle's law. Honestly, it's the single most important rule in diving. All it really says is this: as the pressure around a gas goes up, the space that gas takes up, its volume, shrinks. And the deeper you go, the more the pressure goes up. The best way to picture this is to imagine taking a balloon with you on a dive. At 10 meters down, the pressure is doubled, so your balloon is now half the size. By the time you get to 30 meters, you're under 4 times the pressure you were at the surface. And that balloon? It's been squeezed down to just a quarter of its original size. Now, here's the crucial part. This isn't just happening to a balloon. It's happening to every single airspace in your body, your sinuses, your lungs, and especially your middle ears. You know that feeling of pressure in your ears when you descend? That's Boyle's law, literally squeezing the airspace behind your eardrum. When you pop your ears or equalize, all you're doing is pushing a little air back in there to balance things out. And this leads to the most critical consequence for any diver. Because the air you're breathing from your tank at depth is also compressed, you go through it way, way faster. Every breath you take is using more molecules of air. At 30 meters, the air is 4 times denser. So that means you're breathing through the air in your tank 4 times faster. This is exactly why managing your air is the single most important skill in diving. So it's not just the volume of the air that's changing under all this pressure. The actual gases that make up the air we breathe, nitrogen and oxygen, they start to behave in some very different and potentially dangerous ways. Which brings us to another rule, Dalton's law. Look, the air you're breathing is always about 21% oxygen and 79% nitrogen. That percentage mix never changes. What does change is what we call the partial pressure of each gas. At 30 meters, under 4 times the atmospheric pressure, you're basically inhaling 4 times the amount of oxygen and nitrogen molecules with every single breath. This is what can lead to some serious problems, like oxygen toxicity at extreme depths. And that leads us to our last big gas law, Henry's law. Now, this one is all about the trip back up to the surface. What it says is that under high pressure, more gas, in our case, the nitrogen from the air we breathe, will dissolve into a liquid, like our blood and our body tissues. And the absolute best way to understand this is with an analogy that every single one of us already knows. Just think about what happens when you open a bottle of soda that you've just shaken up. Right? Inside that sealed bottle, the high pressure keeps all the carbon dioxide gas dissolved in the soda. But the moment you pop the cap, you release the pressure, and that gas comes fizzing out of the liquid as thousands of little bubbles. Well, your body is the soda bottle. At depth, under pressure, nitrogen dissolves into your blood and tissues. If you come up too fast, releasing that pressure too quickly, that nitrogen will form dangerous bubbles inside your bloodstream and your joints. That is decompression sickness, what divers call the bends. So, getting back to the surface safely is just as much a physics problem as getting down in the first place. It's this delicate dance of managing pressure, buoyancy, and of course, time. And the key to that dance is buoyancy, which is all about Archimedes' Principle. It sounds complicated, but it's really simple. An object in water gets pushed upward by a force that's equal to the weight of the water it shoves out of the way. If the object weighs less than the water it displaces, it floats. If it weighs more, it sinks. Simple as that. And this principle is super practical. Let's say you have to lift a heavy 150-kilogram motor off the seabed. First, you figure out its buoyancy. Let's say the motor displaces 60 liters of seawater. That gives you an upward lift of about 62 kilograms. The water is already doing some of the work for you. So the motor's effective weight is now only about 88 kilos. To make it totally weightless, you just need to add about 88 liters of air to a lift bag. And just like that, a massive lift becomes manageable, all thanks to physics. But a controlled ascent is about so much more than just managing buoyancy. This is where it all comes together. As you rise, the air in your gear and in your lungs is going to expand. That's Boyle's law again. And at the same time, going up slowly gives all that dissolved nitrogen in your body time to safely and gradually come out of your system, just like Henry's law dictates, which is how you avoid the bends. It all connects. So, we've thrown a lot of laws at you. What does all this physics actually mean for someone who wants to dive? Well, these aren't just abstract ideas from a textbook. They are the fundamental rules for survival and enjoyment under the water. Understanding this stuff translates directly into the most basic rules of diving. Boyle's law tells you exactly why your air disappears faster the deeper you go, and why you have to equalize your ears. The weird properties of light explain why that super colorful reef you saw in pictures looks mostly blue and green when you see it in person. And Henry's law? Well, that's the life or death reason you must always, always ascend slowly. So the next time you look out at the water, just remember that hidden world of physics that's humming away right beneath the surface. It's a place that challenges your senses, that compresses time and space, and it demands respect for its laws. The ocean really does bend the rules of reality. The only question left is, are you ready to dive in and experience it?